This video explains the relationship between NEMA-based signal phasing, which is primarily used in North America, and stage-based signal phasing, which is predominant in many other countries. In the NEMA system, most standard signalized intersections can be controlled using no more than 8 phases, as shown in this example. For now, consider a signal phase to be associated with a particular traffic movement. Each phase is numbered in accordance with the NEMA phase and ring structure, which will be described later. Odd-numbered phases, for example 1, 3, 5, and 7, are used for left-turn movements, while even-numbered phases are used for through movements. A simple rule to remember is that the 2 phases serving one street sum to 7, while the 2 phases serving the cross street sum to 11. A NEMA ring structure typically has 2 rings and 2 barriers, although more rings and barriers are also allowed in modern signal controllers. Phases within the same ring are conflicting and therefore will never appear together. Phases in different rings are compatible and can appear together. A barrier indicates a transition in right-of-way from one street to the other. A NEMA-based phasing plan can be directly translated into a stage-based timing plan, as illustrated in this example with 6 signal stages. In countries where the NEMA convention is not used, a stage is often referred to as a phase. Here is an animation of a signal timing plan showing a side-by-side comparison of NEMA phases and stages. Switching the sequence between a left-turn phase and a through phase is allowed, resulting in different phase or stage sequences. In this example, phases 1 and 2 are switched, resulting a lead-lag phase sequence in the north-south direction. When a protected left-turn phase is not needed, you can simply remove the phase. In this example, phases 1 and 5 are removed, resulting in 4 stages. To run split phasing, where the 2 approaches are served separately, simply use the 2 phases in the same ring, in this case phases 1 and 2, resulting in 5 stages.
One important concept to understand is the overlap. An overlap phase allows a single movement to be controlled by multiple NEMA phases. In other words, a movement served by an overlap may appear in more than one phase.
Let's look at 2 examples. The first case is commonly used for right-turn movements when additional green time is needed. In this example, the northbound right turn is controlled by an overlap consisting of phases 6 and 3. Both phases ensure that the northbound right turn movement does not conflict with any other movements. The second case shows a 3-leg intersection such as a freeway off-ramp. While the eastbound through movement can be controlled by phase 4, it can also be controlled by an overlap of phases 7 and 8. Let's look at how to convert from stage phasing to NEMA phasing. I will show you 2 methods. The first keeps the standard NEMA ring structure unchanged, and the second involves modifying the NEMA ring structure. This case is the same as the one shown earlier, and the 8 NEMA phases and ring structure are shown again here.
Now let's look at another way to convert the same stage diagram into NEMA phases.
In this approach, we use 6 NEMA phases to represent the 6 stages. To assign a phase number to a movement, simply identify the phase in which the movement appears and assign that phase number to the movement. For example, the northbound left turn appears only in phase 1, so it is assigned phase 1. However, the northbound through appears in both phases 1 and 2, thus it is assigned with an overlap of 1 and 2. Follow the same rule to assign other movements. This is how the final NEMA phase and ring structure looks like. Let me show you how this is coded in WaySync. In the timing editing window, type in the corresponding phases, including overlap phases. Next, go to the timing window to modify the ring structure. We will place all 6 phases in the same ring. Arrange the order of the phases and adjust the phase splits. Now let's watch a side-by-side run of the 2 NEMA codings. On the left is the standard dual ring structure, and on the right is the single ring structure. Both represent the same timing plan. Now let's look at another case, which is not common in the US but is seen in many other countries, where each intersection approach is served sequentially, essentially split phasing. Method 1. Follow the NEMA standard phase and ring structure. Since the eastbound approach appears in 2 stages, it is given overlap of phases 4 and 8. Let's watch how to code it in WaySync. Put in the correct phases and adjust sequence and phase splits. Method 2. Use sequential phases and adjust NEMA ring structure. Similarly, eastbound through is an overlap of phases 1 and 3. Let's see how to code it in WaySync. First, put in the correct phase numbers and adjust the ring structure if needed. Now let's watch the animation of the timing plan. I hope this tutorial has given you a clear understanding of how to code stage-based signal timing in WaySync. Thank you for watching.